In this video, I'm going to go through the questions that's shown. It's from page 43, number 25. There are three parts. So the first part, it says, we've got a car traveling at 45 kilometers per hour, slowing down at a constant 0.5 meters per second squared by just letting up on the gas. So in other words, they haven't applied the brakes, and so that's why there is a very small rate of deceleration. Remember, the word deceleration is an English word meaning slowing down, but we call it acceleration in science. We're looking for the distance it travels just before it stops. Okay, so when we're going to start this, we're always going to start by writing our SUVAT. And what's important is we always write down our given information. Remember, we need to have three pieces of information, and then we can find the other two. So in this case, 45 kilometers per hour slowing down, that's our initial speed, that's u. It's going to stop, so that will be 0. We have our acceleration, and I'm going to write it as negative 0.5 meters per second squared. Now that's important because my initial speed was 45, and I've written it as a positive number. So the fact that it's slowing down in a positive direction means I need to have a negative value there. Now, the last thing I always recommend you do is to put a question mark on the letter that you're looking for. In this case, distance. Don't forget that's what S stands for. Now, before I go much farther, I need to look at those units. My initial speed is in kilometers per hour, but my acceleration is in meters per second squared. I'm not told what units to put the final answer in, so I have a choice. And it's a lot easier to change that speed into meters per second than it is the acceleration into kilometers per hour squared. So let's start by writing 45 kilometers per hour, and I'm going to write the units like fractions. Now, in order to change these units, I can multiply by things as long as I'm only multiplying by the number 1. And that means, remember, like 4 over 4 or 55 over 55, that actually is just multiplying by the number of 1. In this case, I'm going to write 1 hour up here, and 1 hour is 3,600 seconds. Now notice I have to write it in this way so that my hours will cancel out. But that would leave me in kilometers per second, so I still need to change those kilometers into meters. Again, I'm going to put the kilometers on the bottom, so they'll cancel out with the kilometers that are there, leaving behind 1 kilometer is 1,000 meters. Remember, those two things are identical, so I'm not actually going to be changing my speed by just changing these units. Now, I'm going to pick up my calculator, and how I do this is it'll be 45 times 1,000 divided by 3,600. I can ignore the other ones because they're just the number of 1. And when you put that in your calculator, you should get 12.5, and I'm left with meters per second. Make sure, if you haven't done that before, pick up your calculator and get that value. Okay, so now, once I've got this so far, I have U, V, and A, and I'm looking for S. So I'm going to go to the SUVAT equations, and we've got 5 of them, and I'm going to look for the one that has just those 4 letters. There's only one of them that has just those letters. And here it is. V squared equals U squared plus 2AS. Okay, now one of our values is a 0, so let's take a shortcut and let's write all over top of it that that is 0. Now what I need to do is rearrange this so I get my S on the left, because that's what I'm looking for. So what I'm going to do is I'm going to take my U, I'm going to move it to the other side. And right here it's being attached by by addition. So in order to remove it, I'm going to have to subtract it from both sides. On the right it cancels out, and then on the left I'll be just left with negative U squared. Now if you take a look, these things are attached by multiplication. Okay, in order to undo the multiplication, I'm going to divide both sides by 2a. Okay, remember they're going to cancel out. That leaves me with s equals negative u squared over 2a. If I put my values inside, and remember that negative is in front of the u squared, so it's going to stay negative. I'll have negative bracket 12.5 is squared over 2 times, don't forget this is negative sign, negative 0.5 meters per second squared. Go ahead, pick up your calculator. You should get 56.25. And if you look at all the numbers I've been using so far, I'm using only 2 significant figures. So at most, I should round that to 156 meters, or you could have given me 160. Remember, your math can't make your measurements more accurate. Notice the 2 negative signs have canceled out, and I do get a positive distance, which is good because I was starting at the beginning with a positive velocity, and a positive velocity means I'm going in a positive direction. So my distance should end up being a positive number as well. Okay, so let me get rid of this and we'll start doing part B. In part B, it's asking us to figure out the time it takes to stop. Now, we could go and use this number 156 that we calculated in part A, but I'm going to suggest we don't in case we made a mistake that might give us an additional mistake. All right, so let's say here, now we're looking for time. Again, go back to those 5 equations of SUVAT and say, I want now to have an equation that includes U, V, A, and T. Find the right equation with those 4 variables. There is only one. Okay, I hope you got it. Now, again, shortcut. Let's go and get rid of this value of 0. Makes our algebra so much easier. And we are going to have to isolate for T. Now, right now, T is on the bottom. So if I want to get T equals, I'm going to have to multiply both sides by T to get it to the top. These will cancel out. I'm then going to get rid of the A on both sides, and I'm going to be left with T equals negative U over A. If you put in your numbers, you should be able to get 131 seconds. I'm going to leave that for you to make sure you can get the right answer. Okay, so the next part of the question says, calculate the distance it travels during the first and fifth seconds. So let's first assume that means how far did it travel from t equals 1 to t equals 5, from the first to the fifth second. I think it's a little awkwardly worded. Okay, so a couple things about this. Our equations will be a lot easier if we think about what we have going on. So what I'm going to do is write down my SUVAT for the distance after 1 second and the total distance after 5 seconds. Now there are a few different ways that you could do this question. Notice what I've got here. I can figure out how far it traveled after 1 second. And then I have a second part saying, if I still started with that same 12.5 meters, how far would it have traveled after 5 seconds? So if I want to know how far it went between the first and the fifth second, I'm just going to subtract these two numbers. Now, what you could have done as well is you could have said, wait a second, let me calculate the speed it's going after 1 second. What's its final speed after 1 second? If I did that, its final speed after 1 second could be then my initial speed at the beginning of the first second to the fifth, and I could use it in my U, V. Well, we don't know that. I'm looking for this. I would know that my time in this case would be 4 seconds, and I would have my acceleration -5. meters per second squared. So I'd have to calculate what was the speed it was going after 1 second, put it in this equation, and then say that was my new initial speed. How far does it go in the next 4 seconds? Either way works. I'm going to go and I'll show you what I got for my values written there in yellow. Now, if you go and find the distance it travels, I need the equation that has those 4 variables. You can see I've selected it there. I've written my substitute in my values, and you should get 12.25 meters. Now I'm going to use the exact same equation on the other side, but in this case, my time is now 5 seconds, and you will get a value of 56.25 meters, which means the distance between those two that we're looking for is just going to be subtracting those two values, and you'll get 44 meters. Now, I told you about the other way of calculating, not because I want to mess you up, but rather I wanted to show you that there are multiple ways of doing this question. But if you do it right, you're still going to get the same answer of 44 meters. I hope that helps you go through some questions with SUVAT.